Good morning one more time from me and my stupid mic here. I hope it's loud enough now. So, today we're talking about the mole and Avogadro's number. This is one of the most important things in for any lab work, for any chemical calculation, and that includes calculations related to environmental science, biology, medical science, and so on. So, what is a mole? If you look at these numbers here, and if you remember what we did in Unit 1, you will remember that I said that the mass number of each element is connected to its mass. Technically and by definition, the mass number is the number of protons plus neutrons, remember? And also, there is an assumption that, for example, for lithium, 7 means that one atom of lithium has a mass of 7 AMUs, atomic mass units, because each nucleon, each proton and neutron have a mass of 1 atomic mass unit. But atomic mass units are too small for us. We want to calculate in grams, and you saw in some assignments and in some practices that it would say, for example, for lithium, that lithium has a mass of 7 grams per mole. So what is a mole? I like to think of a mole as a bucket. It's a unit for amount that is specifically designed for chemistry, and the reason why is because the ratio in which the element reacts is very much connected to the mole. You will see later what that means. I just want to mention it. So, for now, because a AMU is too small, and an atom, if you want to measure the mass of one atom in grams, that's very small. So we don't really involve a mass of one atom into anything, but we do involve moles. And you will find many definitions of what a mole is in many books. I encourage you to ignore them because they're mostly stupid and useless for practical purposes. What I want you to remember is just this. A mole is an amount of element or compound that has a mass that can be calculated from the periodic table. What do I mean? 1 mole of hydrogen atoms has a mass of 1.008 grams. 1 mole of lithium atoms has the mass of 7 grams. 1 mole of boron atoms has a mass of 10.81 grams. So a mole is just a huge number, and it's a very specific number. It is this number. Avogadro's number is the number of particles in 1 mole. What does that mean? That means 1 mole of boron has a mass of 10.81 grams, and 1 mole of boron is this many atoms of boron. 6.02 times 10 to the 23. 1 mole of carbon weighs 12 grams, and a mole is an amount of carbon that contains this many particles of carbon. That is the best and the only definition of what a mole is and what Avogadro's number is that you want. It works the same actually with molecules. We don't have to only take the elements. Let's take the example of water. So 1 mole of water has which mass? Let's see. So to calculate the mass of a molecule, so if I'm talking about carbon, that's just an atom. But water, this is a molecule that is made of 2 hydrogens and 1 oxygen. So we need to add them together. So let's see. The mass of oxygen is 16, let's say. And the mass of hydrogen is 1 gram. So water is made out of 2 hydrogens, 2 times 1, right? Plus 16. So the mass of 1 mole of water equals to 18 grams, and that mass contains 6.02 times 10 to the 23 molecules of water. Molecules. So if we're talking about an atom, such as hydrogen, then 1 mole contains 6.02 times 10 to the 23 atoms of hydrogen, and the mass is, right, 1 gram. If we're talking about a molecule, then we use all the elements here from the periodic table that we have in that molecule, add them together, and pay attention. 1 hydrogen is 1 gram, but we have 2 hydrogens here. So we multiply that 1 gram by 2, and we get 18 grams. So this is extremely important. It seems very simple, but I will give you some practices. For example, a lot of the times in chemistry, we are not working with 1 mole of anything. 1 mole is a big amount. Let's talk about, for example, carbon dioxide. So CO2. So 1 mole of CO2, how many grams does it contain? So CO2 is made of 2 oxygens, each is 16, so that will be 32 plus 12. So basically you've got 12 plus 2 times 16, and that will be what? 32 and 12, 44 grams. So 1 mole of carbon, let's divide that out. 1 mole of carbon will be 44 grams. But 44 grams, you will see when you go to the lab, that's a big chunk. You don't in the lab we literally work for like the teeny tiny small amount of powdery thing or something dissolved in water, like 1 gram, 2 grams, sometimes 0.1 gram. So we don't often work with 1 mole of anything. Let's say that in the assignment it tells you that you have 0.012 moles of CO2. So let's say we want to calculate 0.012. That's just horrible. 12 moles of CO2. And then I want to know mass. How many grams of CO2 is in 0.012 moles? This is easy to calculate just by multiplying, but I just want to show you one method that you want to use when you're working with moles and Avogadro's number and all this, and that's proportion. Proportion is something that it's an old method that I learned in high school and has served me well for a very long time. So I know I can calculate from the periodic table that 1 mole of CO2 has a mass of 44 grams, right? I know that because that's something I can just calculate from the periodic table, right? But I want to know 0.012 grams. Sorry, not grams. That's moles of CO2 is X, which mass? You make a proportion like this, you will never make a mistake. And you can use this for, you can put here number, Avogadro's number, you can put whatever you want, as long as the first unit here is the same as the first unit here, and the second unit here is the same as the second unit here, so this is in grams, you're never going to make a mistake. Now, the next thing you do is you multiply this with this, and you multiply this with this, and you equalize those two things. So you will come out with 1x equals 0.012 multiplied by 44. And now you can very easily calculate the mass of that 1 mole. Let's try something more complicated, although you will see as we go through these, you guys are really good in math, and this is very simple, so there is nothing actually that can be so difficult. So let's say I want to calculate 0.7 moles of H2O contain how many molecules? I want to know X molecules. So how many molecules do I have in 0.7 grams of H2 or 0.7 moles of H2O. Again, I can make a proportion. So how much is 1 mole? You always come back to the mole. So 1 mole of H2O is 2 hydrogens, that's 2, and 1 oxygen, that's 16, so 18 grams. But I don't want grams now, right? I want Avogadro's number. 1 mole of anything always has 6.02 times 10 to the 23. So I can just write 1 mole has 6.02 times 10 to the 23. But I don't have 1 mole. I have 0.7 moles has how many molecules? And now again I multiply the inner and the outer, and I'll get 0.7 times 6.02 multiplied by 10 to the 23 equals 1 multiplied by x. And you can see I can easily calculate that. The most difficult situation that you'll get with something like this is, for example, turning grams directly into Avogadro's number, into the number of molecules and atoms. So let's say I say I have 5 grams of H2O. How many molecules? How many? X molecules, right? So again, you come back to 1 mole, but you can just turn it into grams. So 1 mole of water is how many grams? Again, you go 1 times 2, that's 2, plus 16, 18 grams. So 1 mole of water has the mass of 18 grams, and how many molecules it has? 6.02 times 10 to the 23rd. So you just write, if 1 mole, which is 18 grams, has 6.02 times 10 to the 23rd, then I have 5 grams now, right? Then 5 grams has how many molecules? And again, you just go inner and outer, and you solve the equation, and you're done. So we will first practice this, and then we'll come to the other questions about moles. Do the practice, is going to be really long. Thank you.